So let us discuss problem number 1.67. So let us first make the diagram and then we'll discuss the problem. So you have inclined plane, and this inclined plane makes an angle alpha with the horizontal, and there is an object of mass m, and this mass is basically pulled with a force, and this makes an angle beta with this line. So this is the parallel to this, so this makes an angle beta. Are you getting? So this angle is beta. So now let me read the question. So mass of this is m, figure 1.13. Now let me read the question. So a bar of mass m is pulled by a means of a thread up an inclined plane. So this is a thread. So there is a thread that is basically used to pull this mass up the inclined plane. But now the force is not along the incline, force is along this direction, that makes an angle beta with the slope of the incline. This means now this thread has some tension, let us say tension T, or you can say force. So we apply a force in this thread so that this thread will have a tension, and now this tension will have a one component in this direction, one component in this direction. So this component will try to move this block up. Now question says the coefficient of friction between these two blocks and plane is K. Coefficient of friction is also given to you. Find the angle beta so that the tension in thread should be minimum. So we have to find beta. So what is the angle beta? So that tension is minimum. So we require a minimum tension. Are you getting? So how we will proceed? Now this is just pulled. This means acceleration of the system is 0, just pulled without any acceleration. So I want to pull this block with a 0 velocity, very slow velocity. So I can say acceleration is 0. So this system will have acceleration of the system is 0 along the incline, because we can assume this system is going very slowly up the incline. So very slowly up the incline, slowly going up. So up the incline we will have 0 acceleration. Now things are very easy. We can only draw the free body diagram. So let us draw the free body diagram for this block. We will have a tension. This angle is beta. This angle is alpha. The forces acting is, so I will have in this direction, everybody knows mg cos alpha. In this direction we will have force, that is mg sin alpha. So this is mg sin alpha. Now this block has a tendency to move up, so there will be a friction in the downward direction. So friction will be mu times n, that is k times n. Are you getting or not? Now what are the forces in this direction you will have? You will have one force n. So let us say this is n. Another force, that is component of t. So this direction you will have t cos beta. So in this direction you will have t cos beta. Are you getting or not? And in this direction you will have t sin beta. So let me write here itself. So this is t sin beta. Now things are easy now. We can write down the equation. So you see in this direction and in this direction. So along the incline and perpendicular to the incline we can write. So perpendicular to incline, total force N plus T sin beta, in this direction, it should be equals to this direction force, that is mg cos beta, because system is in the rest in vertical direction, mg cos alpha. So you have here, so this is equation number 1. Are you getting? Now we can write equation number 2, that is in this direction. Again acceleration is 0 in this direction, so total force must be 0. So up force you have T cos beta, and the downward direction you have forces, that is Kn. So this should be equals to, or this should be equals to downward direction force Kn plus mg sin alpha. Are you getting? So this means T cos beta is equals to K times N, and value of N we can find from here, that is mg cos alpha minus T sin beta. So N is mg cos alpha minus T sin beta plus mg sin alpha. Are you getting? Now if I take T this side, so I will have T cos beta, and this comes this side, so we will have plus K sin beta is equals to, you will have K mg, I can take common, so I will have sin alpha plus cos alpha. Are you getting? Oh, not, I cannot take K common because this mg sin alpha, so I can simply take mg common, so you will have K cos alpha plus sin alpha. You can verify yourself. Are you getting or not? So you will get this value. So from here I can write tension is equals to mg sin alpha plus K cos alpha divided by cos beta plus K sin beta. So this is the value of tension. Are you getting or not? Let us copy this one and check whether you are getting this tension or not. Now things are now easy. This, if you see, this tension is a function of beta. So if you change the beta, you will have different tensions. So we have to find, in the question we say, find out the beta for tension is minimum. This means I have to differentiate with respect to beta and put it to 0. That is, tension is minimum. So what will be the condition for tension to be minimum? That is dt by d beta, it should be equals to 0. So now if you differentiate this equation, and you can find the beta yourself. So let me wait for some time. Let me see how many of you are able to do this one. So if I differentiate this equation, so let me use the next page. So what we will have, if we have differentiated this equation, so the upper part is not a function of beta, so I can treat this as a constant. So T is mg sin alpha plus K cos alpha, and this is equals to divided by 1 by cos beta plus K sin beta. So this is the function. Now this is a constant because this is only a function of beta. So what we will do, so let us differentiate this one. So this is a constant, so dt by d beta. So there is some constant, so let us say some constant, I can say c. This whole constant I can call c. This is 1 by something, so I can differentiate u by v. So let us say u by v, if you differentiate, so 0 minus, so this is u, this is v, so you have to leave this one and differentiate 1 is 0, minus, leave this one and differentiate this one, so cos beta is minus sin beta and sin beta is plus K cos beta. Are you getting? This divided by, we will have this divided by whole square of this whole term. So cos beta plus K sin beta, this is whole square. So if I put this is equals to 0, what I will get? I will get sin beta is equals to, so I will get sin beta is equals to K cos beta. Are you getting? So that is tan beta is equals to K. So this I will get. So this is the required condition, that is the tan beta is equals to K for this tension to be minimum. We also know K is the friction coefficient is related to angle of inclination by K is equals to tan alpha. So I can also write K is equals to tan alpha. So angle of friction, so you see if you have some slope angle, this is alpha. Now friction coefficient is basically related to this angle alpha in limiting situation. So I can say K is equals to tan alpha. So I can say beta is equals to alpha. Are you getting or not? Because K is equals to tan alpha, so tan beta is equals to tan alpha, so beta is equals to alpha. In this case you will have tension is minimum. You can also find what is the value of tension. So you see in this equation you can plug the value in the last equation for tension. So we have a value for tension. If you plug the value for tension, you will get the tension value. So I think you can do this one yourself. So what you have to do is you can plug the value of beta here. So you will have, and beta is equals to alpha, this is equals to alpha, and K you can plug K is equals to tan alpha. Or if you want, you can leave this K simply, and then you can find what is the value of tension minimum. So if you do this one, you can plug, so let us say mg sin alpha plus K cos alpha divided by beta is equals to alpha. So we will have cos alpha plus K sin alpha. Are you getting? So this is the minimum value of tension. So this is the minimum value of tension. You can also find this value in terms of tan alpha also. So if you want, you can write so sin alpha plus K cos alpha, and I know tan alpha is equals to K. So basically what I can do is I can tan alpha, I know tan alpha is equals to K. So sin alpha is what? So tan alpha is K, this means 1K, this is root over 1 plus K square. So if I want to plug this value, sin alpha is 1 by root over 1 plus K square. Cos alpha is nothing but K by root over 1 plus K square. If you plug these values here, formally for denominator, because I want answer in the form that is given in the book. So mg sin alpha plus K cos alpha, this divided by, you will have cos alpha is nothing but K by under root 1 plus K square, and this sin alpha is K. So sin alpha is basically, you will have tan alpha is 1 by K, so sin alpha is K into this, so K by 1 plus under root K square, you will have this value. Are you getting or not? So let us check this, you are getting or not. I think there are some missing, because I will have some different value in answer. So tan alpha is K. So if I see this tan alpha is K, so tan alpha is K, oh my god, so this is tan alpha is K, so this is K by 1, so this is K, this is 1. Are you getting? So tan alpha is K, this means K by 1, so this is, so sin alpha is K by 1 plus K square. Cos alpha is simply 1. So you will have here 1, and here you will have K square. So now K square plus 1 root over K, so you will have simply mg sin alpha plus K cos alpha divided by root over 1 plus K square. So this is your answer. Are you getting or not? So let us verify, let us copy this thing. Please do fast. And in this case, one important point we have, because tension is a function of beta, I have to minimize this tension, I have to differentiate with respect to beta and then put it equals to 0. Another important point is friction coefficient K is equals to tan alpha. If the inclination is such that this is a critical inclination, that if in this inclination a block just slips, so tan alpha is equals to K, we can always write.